Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which helps us in printing level order traversal of a general tree. First, let us take an example. The approach to this problem is similar to level order traversal in a binary tree. We start with pushing root node in a queue, and for each node we pop it, print it and push all its children in the queue. In case of a generic tree, we store child nodes in a vector. Thus, we put all elements of the vector in the queue. Now, let us have a look at the algorithm. Let us also have a sample tree to test our algorithm. We pass the root node to level order traversal function, so root points to 1. Since root is not null, we create a queue and enqueue the root node which is 1 into the queue. Since queue is not null, we enter the while loop and take a variable n which stores the number of elements in the queue. Since there is only one element in the queue, n will be equal to 1. As n is greater than 0, we enter the inner while loop and dequeue item from the queue and print it. So, we take a node p which points to the front of the queue. Next, we pop element from the queue and print p. Now, we enqueue all children of dequeued item using a for loop. Note that we have the children of a node stored in a child vector. So, we run a for loop from 0 to the size of child vector of p and push the elements of the vector into the queue. Since children of 1 are 2, 3, 4 and 5, we enqueue 2, 3, 4, 5 into the queue. Next, we decrement n, so n will be equal to 0. Since n is not greater than 0, we break out of the inner while loop and print new line between two levels. We call while loop as the queue is not empty, so n will be equal to 4 as there are 4 elements in the queue. Since n is greater than 0, we enter the inner while loop and one by one we pop the front element of the queue and print it. So first p will point to 2 and 2 will be dequeued. Next, we enqueue the children of node 2, so 6 and 7 will be enqueued. Then we decrement n. We continue with the inner while loop and now p will point to 3 and 3 will be dequeued and printed. Then we decrement n and continue with the inner while loop. Now p will point to 4 and 4 will be dequeued and printed. Next, we enqueue the child of 4 which is 8 into the queue. In the next step, we decrement n. We continue with the inner while loop and now p will point to 5 and 5 will be dequeued and printed. Then we enqueue the children of node 5 into the queue, so 9, 10 and 11 will be enqueued. We decrement n. Since n is not greater than 0, we break out of the inner while loop and bring cursor to new line. Now n will be equal to 6 as there are 6 elements in the queue. Since n is greater than 0, we enter the inner while loop and one by one we pop and print elements of the queue. Also, since all nodes in the queue are leaf nodes, nothing will be enqueued and we decrement n one by one. Finally, n becomes 0 and we break out of the inner while loop. Also, since queue is empty, we break out of the outer while loop as well and we have the final output. With this, we finish execution for this program. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.